Hey, everybody. I know we're going to get started in just a minute. We're running a little behind technical difficulties at station. Let's see here. Just get myself together. How is 2022 for you, Sujan?
I can't complain. I cannot complain actually about 2020, 2021, or 2022.
Good.
I've been blessed and things have gone well for me and my family and for Chariot. So no complaints from here.
Good.
Apparently my persona is being resurrected here, Snooze Doggy Dog. But my name is Sujan Kapadia for those that are tuning in maybe for the first time.
And I'm Ken Rimple. I do our training and mentoring services as well as some consulting. And what do you do here now besides everything?
It's a good question. A little bit of everything pretty much. So, yeah.
That's what we do here. We do a little bit of everything. That's called consulting, right? All right. Well, hey, so here's the, we used to call these, well, we still call them TechChat Tuesdays because I don't want to change the name. And Becca did a great job on them. So what we're going to do starting in 2022 is we're changing this up a little bit. We are going to hit the microphone and throw it. So that's called professionalism. After that, what we're going to do is we're going to switch it up so we have a little bit of developer news, probably about 20 minutes or so of them. So we're going to do a little more of a kind of a dive bomb through them. And then after the developer news, we're going to pick a topic and discuss it and or have an interview or discussion with somebody. So up this week, after we do our development news, we're going to have Kent C. Dodds. He's a former speaker at Philly ETE. He was here a couple of years back doing his talk on, oh boy, back then it was probably early React or it might have been Angular even. But he's been doing single page application development for a long time. And he just joined the Remix Run team. So because Remix is another one of these super fast accelerated front end frameworks that have come out recently. And I didn't know a lot about it when I was researching things like Next.js, which we're going to talk about in our segment. I figured who better to talk to than Kent, who just joined and apparently has been working with it for a year on his own sites before he went and joined them to do teaching and mentoring and getting the word out on Remix Run. So that's our goal today. We'll talk about development news. We will talk about, this single page applications and what makes them slow and, Google's way of ranking them and figuring out how things can accelerate. And then we'll look at some trends in how single page apps have been sped up, browser applications have been sped up over the last couple of years, and feature Remix Run at the end. So that's our goal for the show today. Before
right now,
what's that?
I'm so lost with this new format. And if you call right now, we'll also throw in now.
You can win a new car. No. We're not going to do that. But I do want to turn on my browser. So let's do that. Share. That's the one I want. We're going to look at this. All right. So before we look at that page, however, I want to show people Philly Emerging Tech. Everyone can do this. Everyone except in our office can do this. Oh, man. All right. Well, you're just going to have to take my word for it. Our DNS isn't set up yet. Philly Emerging Technologies for the Enterprise Conference is coming up. And so the show is coming up on April 19th and 20th. And it is now going online only. So the issue is obviously we've got COVID flying around. We were going to be in person with a hybrid format where some of us could stream and others could be physically in person in a smaller, reduced capacity. But it's just with Omicron flying around, it's just not safe. So we made the decision to run ETE virtually one more year. We're hoping this is it. I said that last year, but let's hope this is it, and we'll do in person again. That said, we had a lot of good engagement last year or for 2021 Philly ETE, and we've got a lot of good things coming up. Sujan, what are you excited about with ETE? And I know we both can't browse it at the moment because of DNS.
So I actually still need to look at the latest set of talks that have already been lynched, but I just wanted to kind of emphasize what you said about last year. I mean, it went really well. We've gotten really good at running these virtually. The back and forth communication with attendees and questions that they've asked and the answers by speakers has been awesome. We had amazing talks last year. So if you just want to get a taste or preview for what's coming this year, please take a look at talks from last year and prior years. I think there's going to be a lot of stuff. So yeah, I'm bummed that it's not in person, but excited that we're still moving forward with it.
And the technical difficulty glitch is simply because we've switched to the live online registration platform for everything, and our internal DNS is self-hosted, and we have to point the Philly Emerging Tech to the right place. So that's just a snafu that I forgot to test before I walked into this office. But anyway, we have speakers, including Cory Doctorow, who is a really big futurist and sci-fi writer, and also he covers a lot of internet issues out there. So really good stuff. A lot of what you would expect from us in terms of technical talks and acumen. We've got people talking about a whole bunch of, here it is on my mobile site, a whole bunch of technical talks such as, let's see, we've got someone from Lightbend to talk about, I guess, the Scala world, Kiki Carter. We've got our own Drew DeCarm is going to be speaking about, I think, single page applications in CSS design. We have, let's see, Richard Feldman is coming in for a full deep dive on the Rock programming language, which we've had on here a couple of times. Jessica Kerr is back. She's a great speaker. She's now working for honeycomb.io. And so she's going to bring a really good talk, like our Samathasy talk and all the other ones that are really awesome.
That's awesome. Honeycomb, a couple of our clients use it.
What is Honeycomb, by the way?
So my only exposure has been with Java, but you basically get instrumentation and monitoring. So you like plop in the Honeycomb library, it instruments your code, and you get a lot of integrations with certain libraries out of the box. But performance monitoring, application monitoring, analytics, stuff like that. It basically has an agent that will push, scrape and push that data to a server, and then you can view it. So you get a lot out of the box just by plopping in the jar.
Oh, that's great. And Josh Long will be back. There's been a big move for Spring. I know the newest version of Spring is going to only run on a very modern version of Java to take advantage of a lot of the newer, probably bytecode and performance and native compilation features. And I'm going to hit that thing one more time. It's going to drive me crazy. And so many others. It's going to be 2 days, 3 tracks, and it's all going to be streamable right to your computer. Tickets are $150 right now. So for the next couple of weeks, you can grab tickets. I would do it now. Hey, it's only 2 days of your time. You're going to have the videos later on. You'll be able to look at them earlier than everybody else will. And it's just a great conference. We're pretty engaged with our people too. So we have used, in the last couple of years, we've used Slack for streaming, chat and things like that. I think that's what we'll use this year. We're still working out some of the details. But we're certainly going to have a lot of engagement with everybody, and people can, talk to each other and ask questions and sync up, and we can, just be together, at least virtually, for Philly Emerging Technologies for the enterprise. All right, so let's go into then the first article. Let's talk about, I threw yours up front because it's kind of a cool one. Snoop Doggy Dog, Snooch Doggy Dog. So Flutter is one of these one of these semi-new concepts of a cross-platform native kit up application where it uses some sort of programming, in this case, Dart, right? Yes. Which would be cross-platform, so you don't have to know Swift or the SDKs for Android directly. At least that's what they promise to get cross-platform app development done. But like React Native and a couple of other ones out there, NativeScript, I think, kind of a number of these are out there. And talk to me about what Jorg van der Hoen in Better Programming.pub has to say about Flutter.
Sure. So like a lot of folks, when he initially looked at Flutter, was really excited about it, and the developer experience, user experience is really good. It takes a component-oriented declarative approach to putting together UI. So instead of building things with XML files and stuff like that, you're basically putting together a tree of components and declaratively saying the things you want it to behave like. And so you're programmatically building something, which is what a lot of it, React is going that route. Swift is going that route. So programmatically build up UIs very intuitively, and a lot of features right out of the box. Dart is really easy to pick up, and like JavaScript, and it's really active. And Flutter, from a performance perspective, is generally better than things like React Native, because what Flutter is doing is there's an actual native Flutter runtime VM running on your mobile phone, like either Android or iOS. And what they're doing is, instead of like putting things in a web view or anything like that, what they're doing is they're or doing some sort of crazy like compilation down to native code, and it's widgets. It's rendering natively the widgets. So you're just doing like direct to graphics frame buffer rendering, and therefore it has high performance. Now, obviously, a lot of other it does other things, but anyway, once you get past that, what this article really gets into. So this, how do we, Gorg or George? I'm not quite sure how to pronounce.
I want to say Georg, but I'm probably wrong.
He really succinctly describes a lot of the pitfalls or issues they had with converting things over to Flutter. So one being that instead of having one SDK that's maintained by Apple or Android and getting a lot of features out of the box, you have to use a lot of different third-party dependencies to get the same set of features. And a lot of the what you would imagine to be core functionality is left out of the Flutter core. So it's left up to volunteers and open source committers to do. So you get varying degrees of quality and maintainability and how up to date they are. So that is an issue, that your surface area for third-party dependencies increases a lot. So now he makes a great point about when you have to borrow someone's code or functionality, one day you may have to pay for that. So
yeah,
it's a form of technical debt. It's good technical debt, but it can easily become unwieldy, get out of hand. So that's one thing. Another thing was that there are known bugs that people submit, and the Flutter team's good about responding back to, but they have like more than 8,000 open issues, and they can't get to every bug. So there are a lot of open bugs that haven't been resolved yet that are showstoppers for this person, because of what they're doing with WebView and HTTP server in particular. It was basically like they couldn't finish the app and it wasn't working. It was too buggy for them based off of that. So between all these dependencies, adding multiple layers, and bugs not getting resolved in a timely manner, it's hard to take these things into production and rely on them. Another great point he makes is that with Android or for iOS, for example, or something, one of the libraries he's using, it was easy for him to, it was an XML library for XML DOM parsing that he was using. It was easy. There was a bug in it, but since it was written in the same language as his mobile app, it was easy for him to go in, patch it, and update it easily and put it in and submit the resolution back to that project. Whereas he goes with Flutter or other, you're now working across different languages and layers. So you're not only doing like Swift or Android, you're also now doing Dart, and you may be doing some native, the native plugin stuff underneath for each platform. So now maintaining things or fixing things becomes a lot harder. You're not truly working with one language. You're actually having to dive into each of the languages and know them to be able to fix things. So overall, his recommendation is that, cross-platform is not the way to go because of the number of dependencies and maintenance and different layers you got to jump through. And it makes a really good case for it.
Yeah. Sorry, go ahead. Didn't mean to jump into you there.
No, sorry. It makes a really good case for not doing cross-platform apps, but sticking with native.
Right. Okay. Yeah, good one. So we're going to have all the links in the show notes as well. So this is, again, at betterprogramming.pub, and Georg von der Hauen is the writer of that article.
Yeah.
The next one I thought was kind of humorous. I know I'm kind of playing with fire because I don't want to steal the thunder. I know we have someone who's actually working on the NFT standard who's scheduled to speak at ETE, and I'm certainly not like tarring everyone with this, but this guy, this is a really interesting interview to listen to just to get an alternative perspective on non-fungible tokens. So allegedly the way these work is you go to a website and you purchase what should be your individual image licensed to you for some piece of art, for example. And so those are what NFTs, to my understanding, should be. What this person talks about, Jeffrey Huntley, he created an automated tool, I guess, or something that right-clicked all the non-fungible tokens in the world from one blockchain and uploaded them to a website to make a point. Now, what he did was he illustrated a couple things. And this is what I got out of the video. It's definitely worth watching. We'll post the YouTube video itself. I think it's an interesting one. The guy who we're seeing in the interview lives in Australia and codes out of his van and travels all over the country in Australia, kind of like, working from a, I think he calls it van life or something like that. But he's an interesting cat. And I've seen a couple of his articles before. So that's the guy that did this. And this guy interviews him. Jeffrey Huntley's his name, this guy. So a couple things that I took notes from the video. So the one thing is an NFT in the blockchain isn't the actual image, because it would be too big and the blockchain would be huge if the actual artwork is in there. So it points to a link. So it's metadata that points to a hyperlink, probably with authentication keys or whatever in it, for you to get your piece of art. So what does it point to, right? Is it always going to point to something that's truly permanent? Why couldn't they sell the link to more than one person, which has been done, I think, in the past? The other things that I've noticed in the interview that we're talking about is like, things can be, obviously blockchain generally is public information. So do you really want to have all that information out there? Now, maybe this is the kind of stuff which could be interesting for our ETE talk with the guys working in the NFT standard, maybe about like rights management and ownership of these things, to see whether are there holes in this current approach and what are they trying to do to kind of close those holes.
I mean, I haven't seen this video, so just that disclaimer, and whatever opinions I have are uneducated opinions on NFT.
Me too.
To me, it's akin to, like, let's say I autograph a baseball card or something, but I only autograph it once. So now I have like this one special autograph copy from this athlete or celebrity, and it's worth a lot of money. So it really comes back to, you can copy these things and duplicate them. I guess the perceived value is that there's an authoritative source or signer of that first copy. So to me, it goes back to like the value. If you look at how art is valued, there's a great article out there. I'll have to find it. It's a very bizarre and arcane world of how art gets valued by very rich people and museums.
I saw that.
It's really cool. And again, it's like humans just assigning arbitrary value to things. To me, this is the same exact thing. The underlying technology is cool. The fact that you can sell it for a crap load of money is just our human craziness.
It is. And so what the guy actually did, he didn't actually download all the artwork. What he did, because it was kind of a prank, is he generated large random byte streams for each of the images. So I think it's like a 15 terabyte or something crazy file that you could download, but all you get is the publicly available blockchain URLs parsed out.
So we should create an NFT of random white noise, but it'll be our random white noise.
Curated white noise. Or pink noise. Pink noise is actually white noise with a... Let's try that again. Pink noise is white noise in a band of audio, so it's not completely dispersed across the spectrum, which I thought is kind of a fun name for a thing. Pink noise versus white noise. Anyway, and I swear I'm going to figure out how not to hit that stupid thing. 2022, the year where Ken beats up his microphone.
It's almost like a mask, your microphone.
Yeah, it does. And so then, the other thing that I want to take some time, maybe in the next article or coming up, is I want to beat up this Web3 concept, just as a complete side note. So Web3 is apparently supposed to use blockchain and these blockchain, owners to make it so that you're not stuck with all the major, Googles and Facebooks and whatever of the world for your authentication. But then aren't you stuck with the other guys instead? So I want to investigate Web3 from the same perspective and see what it really means, because there's a lot of hype around that too.
Right. I think the idea or the difference from what you cited, like Google and thing, is that this is decentralized and public. So your identity, you own your identity and the data associated with it, and you carry it with you, and it's publicly available everywhere. So it's not tied to any one corporation, but your identity goes around with you. Now, in practice, what does that mean in reality? Where does that physically reside, on whose computers, on whose networks that are controlled by governments? And what does it truly mean at the end of the day if someone can turn a switch on or off and cut your access off? I don't know, but I think the idea is that it would be more democratic. Yeah.
All right. Well, so we'll dig into that, because I'm really seriously curious about that one. Next topic. I just kind of like this one because it seems like someone who is I love the name. Adamalang.org, and this is the blog for this Adama language documentation, whoever this and whatever this is. But the person's name is Jeffrey M. Barber, and I love his byline is Dark Lord. Yes, sir. So his statement is, "Woe unto you for using a WebSocket." And I know it's a useful tool in the right setting. If you have something where you need to be able to send, so WebSockets are, you connect up to a service, and then you've got a two-way communication channel with the service where the service can send you messages at will. And you could also potentially write messages up to the server for it to be paying attention to and working off of. And so he has a lot of like things to think about when using WebSockets, and the way he writes it, I just love it. They are quite funny. So like I love his things. Problem: you'll be lonely, right? So the point is that like WebSockets aren't as standardized in terms of their mechanisms and how they work. When you use them in reality, your logical protocols for them aren't as standardized as, say, let's say REST or polling. So there's all sorts of ways people do it. Everyone kind of does their own logical protocol individually. So that's a concern. He also has, remember there's issues. Well, also most people are doing request response because of the issues with setting up WebSockets and managing them. So you don't have as many people to work with that know what they're doing. And when you need to troubleshoot, you're kind of stuck on your own in a lot of cases. Another really interesting one is, and I wrote this in here. Let's see, where is it on here? What if the client disconnects, but it doesn't say they're done? So for example, it crashes, right? So the server now has a handle to that client, doesn't know it's dead yet, and has to reap the connection. Whereas if you were doing long polling, where we just kind of go poll, wait 30 seconds, poll again, wait 30 seconds, poll again, for example, it's a little more chatter, but individual requests only last for a fraction of a second. So you don't have to worry about dead clients, and you can just assume that they time out because connections time out. What does a timeout mean with a WebSocket? So he asks a lot of really good questions.
Protocol again, basically.
You're right. You're rolling your own protocol, right? You're doing your own flow control, basically, right? Exactly. That's exactly it. So it makes the programming model hard. It talks about back pressure. So for example, when the server really starts getting overloaded and it starts putting things in an accept queue, it's going to really start queuing up and slowing down and then eventually potentially crashing. If it's an unbounded queue, you have to manage all that for yourself. So just considering the fact that WebSockets aren't necessarily a panacea, right? And you really have to do a lot more of the work yourself. So I think this is good to look at if you're considering WebSockets. One of the things he talks a lot about is scaling up. So at certain points, you're going to have to keep increasing the load that the servers can manage and then split to multiple servers. So then what happens if one of the servers goes down? How do you deal with failover? Could you deal with failover? These are all questions you have to kind of ask yourself if you're going to do that. Are you going to be using like a message queuing system? So the WebSocket might hit like an AMQP or whatever you want to call it, or RabbitMQ or MQTT, pub sub, something like that. Again, like you said, you have to roll your own flow control or communications protocol. So it's well done. And then somewhere at the bottom here, he mentions something along the lines of, and I can't find it here in this last second, but he says, you could certainly just poll instead, and polling.
After all, you got to get through the whole article that was like, hey, you could just do polling.
Yeah. And then also he's talking about streaming proxies, for example.
Let me ask you a quick question. You may have said this and I missed it in the description. Does he make a recommendation on a library that maybe does a lot of that work for you and is opinionated about it?
No. Okay. I didn't see one. Now, maybe I skimmed it too quickly, but, he's even asking, like, so for Adama language, I don't know what it is. I'm wondering if the asymmetric client-server model Adama uses, client sends request response and server emits a data differentiable stream, is worth generalizing on its own. So maybe they came up with something on this Adama language that might be more scalable than just pure WebSocket. So anyway, an interesting thing to kind of put in the back pocket and say, before I go down the road of like a very highly scalable WebSocket solution, have I thought of all these things? I thought that was pretty decent. All right. All right, let's see. Here's one I think you flagged. Because I don't remember doing it, but you know what? It's been a couple weeks. This year?
Yeah, so the reason, I brought this up because one, it's just amazing to me that we're at a level in biotechnology that we can do this, and I do consider it a feat of engineering to a certain degree, both bioengineering, human engineering, but also genetic engineering. So this person was a 53-year-old handyman, I guess I don't know the whole patient history, but has had heart issues, but basically was at a point where they weren't eligible for a heart transplant and they were going to die. So they literally had no options left. So the FDA made a compassion, I forget what it's called, like some
compassionate use or something like that.
Compassionate use or something like that, exception to be able to transplant a pig heart into them. Now they've been using pig heart valves for decades, like successfully. That's been going on, but never an entire pig heart. And they've done some things in the past, but the body typically very, very rapidly rejects it. Apparently, there's some sugar in pig heart cells that the human body rejects. Well, what they did was they modified the genes, the DNA, to basically remove that sugar from this pig heart, from this pig rather. And so it's been 3 or 4 days now, and the person's still on a heart-lung machine, but they're alive and it's working. Now, time will tell whether it truly the body accepts it or not. But to find it amazing that they're at a point where they can first grow animals for human organs, genetically engineer them to make them more acceptable by the human body, and then actually carry out the procedure on someone and see them live to tell the tale afterwards. And to me, it's like, yeah, you're open sourcing some of this, right? Your human DNA and pig DNA and genome that's publicly available. They're modifying it, they're refactoring it, and integrating it. So to me, I'm being a little bit extremist here, but it paints a picture far in the future of these things maybe becoming plug and play and programmable to a certain degree. So to me, it's just amazing that they're doing that.
It is. And I'm a little worried about pigs because one of them is going to wake up in the Matrix being harvested for their organs.
I'm glad you didn't I thought you were going to make a babe.
No, I had another joke written down, and this is not funny because, I mean, hey, I'm 52 and that scares me because I'm older, and I understand heart failure is, my father went through that and died at 53. So I'm glad that there are options for people. The only joke I had, which was a obnoxiously stupid joke, was that in other news, U.S. surgeons have just transplanted a pig's head onto a human being, and now he's officially pig-headed. So there we go.
I think we already have those kind of people out there.
There's lots of them.
Yeah. One thing I wanted to so the company that provided this pig heart called Revivicor. Doesn't that sound like some future dystopian company?
I am the president of Revivicor, and come into my van, and we're going to talk about your liver. Yeah, so I'm not sure I like that.
This is my thing on TechChat. On these podcasts, I always bring the crazy dystopian dark.
Hey, that's okay.
But it is like dystopian future is becoming a reality.
It's really wild. I mean, a lot of the things that you would think were a fantasy a decade ago, with CRISPR and all these genomic editing tools, it's just things are changing rapidly out there, and the ethics of it, they kind of keep me concerned sometimes too. All right. I think you put this one up here too. The bedtime story for software developers was for new software developers.
Oh yeah. If you want to say that for last, it's fine. But if you're bringing it up now, that's cool.
I think we are at last. I think unless we missed something, because I want to get to the discussion. Oh yeah. Okay.
Maybe you skip those.
Let me see. Oh yeah. No. Let's come back to this.
Yeah.
I want to cover this one because it's kind of amazing. Kyoto University in Japan suffered a technical error that wiped out 77 terabytes of data on their supercomputer system. And so it happened sometime in December. Apparently erased 34. Oh, I should say, the last article was from AP, and it was byline is Carla K. Johnson is who did it. This one is Gizmodo, Lucas Ropek. And so, yeah, there was some sort of malfunction in the backup system. And so they have HP Cray computer systems. Cray still? Does Cray still exist? I guess it must.
Yeah. I guess it probably cost a lot of money when they bought it. So they're still like, hey, we still need to recoup our investment.
I guess, right? And a data direct exascalar storage system, which can be used by different teams, it says here. Apparently something happened where the backups weren't being properly backed up, and so it's basically wasn't properly doing its work. But they lost close to 100 terabytes of files. And there are all sorts of like research teams where I sure hope someone thought of taking some backups off site, but this is your famous, like, how many copies of the data do you have? Do you have it locally? Do you have it remotely? What formats are they in? None of this has really changed, right? The problem is the data is so huge. How do you get an offsite backup of, let's say, 40 terabytes of data relatively quickly? You know?
It'd be great if university would lose some data, like, oh, hey, you already paid off your tuition.
Lose the right data for us, would you?
Exactly.
Yeah. Lose the invoicing data. That'd be great. Yeah. So anyway, so read that one if you're curious about, interesting, crazy disasters. And let's see, do we have any other? I think this might be it. Yes. Yeah, this is the last one. So let's go on and look at the life of a bytecode language as explained. So this is Better Programming. A guy named Andy, which I guess he runs Better Programming or is on Better Programming.
He's on. He's there's a lot of different bloggers on Better Programming, and I think they're an aggregator to a certain degree.
Okay.
So I don't know if this one points to another website, but I won't go through the whole thing. But he basically took the evolution of Java and the wars between interpreted languages, compiled languages, and then bytecode interpreted compiled languages, and how in story format it's actually really interesting.
Yeah.
And pretty accurate. So I think it's worth a read to go through, and you'll get a chuckle out of it, especially folks that have been through all of these paradigms and have seen the software industry evolve. And for folks that haven't, that are new, I think it's cool to go through to see like how things got to where they are now. So definitely worth a quick perusal.
It took me like 5 minutes. I'm like, yeah. All of it fit in my brain cells of what I went through and saw happen in the industry. My favorite image is coming up. Where is it? This one. Colin is hanging on.
I love the part where Java's like, yeah, we're the kings and bytecode is going to rule, and then like, oh wait, the compiled languages are like, well, your VMs are built on compiled languages, so we're going to cut off your supply, and you're not going to be able to do anything if that one right there. That's hilarious.
So good, so awesome. Yeah, it's a really good, quick, illustrative way of like, here are the different types of language compilation and just-in-time compilation and bytecodes and all this and how they fit together. And the one where you think about like the ecosystem they really created here, right? The bytecode. I mean, there's so many languages that people use. They forget that they wouldn't have been able to use them without like this open bytecode format and VM runtime that Java came up with in the JVM. It's really amazing. All right, cool. Okay, so that's the news. Now let's talk about a topic. So again, this is new, so bear with us as we do this. Yeah, good luck, everybody. So first things first, and let me see here. Can I get stop screen? There we go. A long time ago, there was a little language called JavaScript, and that little language called JavaScript was just scripts embedded in HTML, and everyone hated it. And then it became external files, and those external files got more complex, but then HTML was hard to work with, so there became jQuery, and then jQuery was the cool kid on the block for like 5 or 6 years because it made the complexity of looking up things in the document in the HTML page easier, and handling events easier, and doing different things like animations or processing forms easier, and it became a desktop application. So your browser, think about when you use things like Gmail or whatever, your browser acts like an application. Most apps written today are written to the format called Web 2.0, which is basically the browser is in control of the session with the user. You may download an initial set of pages and content and static stuff, but JavaScript fires things up. JavaScript runs things in the background. And when you click on buttons, you're telling your local browser's JavaScript interpreter to do work for you. And that's what now they call single page applications. You download a shell page with its scripts that it needs to get started. And that thing runs as the desktop app. And that's what we've been doing with AngularJS, and then Angular, and then React and Vue, and a bunch of others that I could name and I forget. But all these things have been basically smart desktop clients written in a browser. Basically what they did in the JavaScript world was what the Java world tried to do with applets and horribly failed because they were 20 U's too early and were not usability people at all, is run a desktop client on a browser. And that's what JavaScript has been. So the thing is, with JavaScript, you can write really non-performant front-end applications with JavaScript if you don't understand things like the request response cycle, or how much data you're piping back from the server to the client, or how much can the client actually store? You know, how can I design things so that I can actually get things done well and quickly? How can I make it so that the user interacts well with the page and doesn't sit there waiting on a lot of, like spinners and things like that? Can they get things done? It's complicated, right? And we've all been wrestling with this with different frameworks. The earlier frameworks like AngularJS, it was really primitive what you could do, and it was really not the most efficient tool, but nothing really existed besides rolling your own otherwise, or coding a lot of it yourself by hand. So over the years, we've kind of evolved in this state where a lot of people out there today are using things like React, a component library that's easy to work with, that you can learn in like a day concept-wise and get started on. But then things like React only do the components on the screen. That's all they do, right? So you've got this application that looks nice, but then you have to get it to go to a database from a server. So you've got to call something. You need a network stack. You want to do animations. You got to figure out whether you want to do CSS animations, you want to do JavaScript animations. Can I use a library? What libraries are out there? Forms are horrific in plain old React because you have to do all the work of the state of the form yourself. You have to figure out whether the form is valid, write your own validation rules, right? And deal with focus issues and things like that, and masks and inputs and crap. So there are forms libraries out there now that the React world has created. Sujan, it's kind of like what you were talking about with Flutter. Like Flutter, Flutter itself is a smaller core, and then you have to go out and get a lot of libraries to get things done. Well, they basically are doing the same JavaScript playbook everyone else is. They're using a lot of JavaScript libraries. And so I've been working on projects in the past where you come in and you've got this stack of dependencies, and someone hasn't updated them in 3 years, and you go to update them and 2 of them are dead. Now, that's not that new of a problem. We had the same problem with Ruby on Rails because Ruby on Rails used a lot of libraries, and you basically, every time you did an upgrade, half your libraries were dead because people abandoned them. So that's one kind of dimension of the problem. The other dimension of the problem is just performance engineering, right? Just figuring out how to make things performant. And the problem with React apps and Angular apps and Vue apps is if you try to treat it as a giant desktop application, out of the box, it has to download all that script, parse and compile all that script in memory, and start up the components for the first view. And that takes time. Also, if you're doing anything kind of restoring state, like let's say you're taking data out of local storage that you threw in there in the browser and you want to bring it back again. If it's huge, it could take 5-10 seconds for that stuff to parse, depending on the computer and how much you've stored, or you might blow past the maximum amount needed to actually show something, and you might get a crash. So there's all these issues with single page apps that all boil down to, I need to be able to interact with this thing quicker so that I don't leave while I'm waiting for it to start. Right. So that's our topic today and that's what we're setting up for talking to Kent C. Dodds about, is this concept of single page application speed up patterns. And it all kind of starts from Google's Lighthouse research and Google's speed metrics. So I'm going to copy this link and share. All right. So make sure I get the right one. I'm taking a few seconds to get the right links up here, so bear with me.
You noticed the ticker tape at the bottom as you were.
Oh, is it doing? I'm a little frightened.
No, I didn't even notice it till now, the advanced SPA patterns.
Oh, okay. Oh, there we go. See? All right. So let me share this here real quick. Share. Yeah, that's Becca doing her magic for us. Share screen. Al next door went, yes. All right. All right. So what we're looking at here is web.dev. And so web.dev is kind of like the Google performance engineers kind of blog about, I believe that's what it is. Google developers about performance and, speed engineering and things like that. And so things like page speed, which is a tool that can kind of tell you where things are running. And one of the articles on here kind of goes through the performance metrics, and I'm trying to find the right one. Web dev performance metrics, Google. Yeah, that might be it. Nope, that's an ad. Well, anyway, let's talk through them because I haven't written down. All right, so there are a bunch of ways of measuring how fast something is. So one of them was, hold on a second. Becca, I'd like to actually run the video. We're going to end our interaction, and then we're going to run the video at the end of it. Do we? Yeah. All right, cool. Thanks. All right. So one of the things is we've got these different kind of metrics. One of them is first contentful paint, or FCP. And what that means is that we think at the point where this metric was created by the team, the minute the first text or image is painted feels like something's happening. So that is meaningful to the user. The problem is that's not that useful, considering if all you do is paint a spinner, or you paint like the headings of a table and it hasn't rendered yet, if you're still waiting on that, then it doesn't necessarily mean that you can do anything with the page yet. So there's a bunch of other ones, and I won't go through all of them, but just to kind of rattle them off. First, meaningful paint, which is when the primary content of the page appears. And that actually was another thing they took a guess against, and they said, first meaningful paint. Bring that up. Right. This was another one they took a stab at and said, this is not a great one because of the fact that it can be skewed by inconsistent results. Is when the primary contents of a page is visible. What is the primary content of a page? Right. Sometimes the metrics can't easily tell that. Maybe you load up what looks like the primary content of the page, but then an asynchronous call goes out and a table renders, and that's the most important thing that needs to be shown. So they've actually deprecated that one. So bottom line is there's a bunch of different ways to try to figure all these things out. Lighthouse, which is the performance tool that we're talking about here, will paint this information and show it for you and say, okay, so first meaningful paint was 3.6 seconds. It may not be reliable based on what you're actually fetching for the real world. And so now what they're looking at is they're looking at the concept of the, where is it on here? Largest contentful paint. And so that one is the one we all look at. So here's the reason we're talking about any of these metrics. The reason is because it's been shown that if you have to wait more than 2 or 3 seconds to view an application, you're going to browse elsewhere. So the whole point, if you overblow your application, make it giant, and it takes 12 seconds to launch, unless people are forced to because they're customer service agents in your office, they're probably going to give up on your app and move somewhere else. So especially for things that are public, you're going to want to make sure that you quickly get interactive. So the largest concept of paint is a metric for measuring perceived load speed, because it marks the point in the page load timeline when the main content has likely loaded. Now, likely is the important part. So this thing will keep monitoring the page as it finishes up any of its initial JavaScript queues. And it might update the metric as it goes along and say, well, I thought the largest contentful paint was 3 seconds in, but now I find out that there's a big chunk that showed up 5 seconds in. So it really was 5 seconds before we can do anything useful. So my point around all this is our big problem here in JavaScript is building something that really takes a long time to parse and load and do something useful with. And so we've done all sorts of things about this. There are frameworks that have come out so for example, for static stuff, right? If you've got a website that's written with a lot of static content and you're trying to render it in a big single page application, well, it's going to be a dog. It's going to be slow by default because you're dynamically fetching something from a content store, parsing it, placing it on the page and rendering it, and not to even mention loading the entire application to begin with and booting it up and showing the first frame. So all that stuff is slow. So there's tools out there like Gatsby and some other ones out there that are page generators that will use things like React and let you write components in React. But in the end, what it does when it builds the app is it goes and it renders data into content. So that's one major thing. And so if you're looking at, like, maybe you're a React developer and you were told, hey, I need to do content-rich sites, and a lot of my content is static. Well, Gatsby was one of the first tools that was really popular out there from the JavaScript React side that were able to actually kind of dynamically, at build time anyway, I should say, generate content so that you don't have to actually interpret it live. You get the entire rendered view ready to show, downloaded to your browser immediately. So the lag time between request and seeing your content is very minimal because it's mostly static. So Gatsby is really useful for that kind of thing. And then you could do things in Gatsby, like you could send it down a JavaScript client that could do like a GraphQL query for dynamic stuff, right? And so you could do things like that and parse things in the URL and, you know, anything that's in there that you need to do dynamic queries, and then do React type stuff on top of that. But it was a little bit limited. The next thing that came out that I think was really useful, and I know we've used this on some projects, is Next.js. And Next.js is something that actually they've created a company for. And so Vercel is the company that hosts Next.js and sponsors it. It is React. It's React with a bunch of different features in it, one of which, and here are the main ones. It has the ability to do static site generation during build. And you can incrementally update those pieces of content. It also does preloading of content before it hits the page, pre-rendering it. So you can say, I want to go and hit this page, let the server do the AJAX request, and then turn it into HTML and render the full page. So that's the next thing we've seen is Next.js. And I know we've used it on a number of projects now, and it really accelerates that time to the largest contentful paint and to interactive with the user. There's also Next.js. And so that one's for Vue. So it's very similar concept-wise. It's another one of these page download accelerator platforms. New in the mix, not to use remix in the terms of remix, but or mix, is another framework. And this one is React-based, is a full-stack web framework called Remix. And it does some of the things similar to what Next.js does, but it does even, I wouldn't say even more necessarily, but it does them in a different way. And so it supports all sorts of features that are similar, and also has server-side features to like accelerate other pieces. And I know it recently launched, and I know that Kent C. Dodds, who is, again, a friend of Chariot and a friend of ETE, our conference, and has spoken for us before. I know he recently left what he was doing to go work for the Remix Run team. So I thought it would be a good idea to get a feel for that, because I think people have done a little bit of experimentation out there in the general population with Next.js, and some people are using it in production, and it's getting a following. But Remix is kind of the new one on the block. So what I wanted to do for the rest of this podcast is I wanted to play an interview that I did with Kent a couple weeks ago before the break, where I asked him all about what Remix is, how it's used, and kind of had him go through some scenarios and some things that it addresses. So I thought this would be a good way of kind of introducing a framework that's starting to bubble up out there to give you a feel for how it works from someone who has used it for about a year on his own and then liked it so much he came to work for this company Remix to find out about it. So Becca, if you want to, let's go ahead and roll the interview with Kent. Full. So thanks a lot for talking to me today. What we want to do is just kind of go over some stuff around React and now Remix Run as a kind of reimagining of React. So I've got a bunch of kind of opening questions for you to go through that kind of lead you into where you want to go, I think, in terms of the tech. But let's start off first with just a little bit of a background for people who don't know you. and are maybe new to React or new to JavaScript programming and might not have run into you yet. So you have a long history with single page applications. I know when I first ran into you, you were doing AngularJS/Angular years ago. So that was like 2015, I think, timeframe when you were working on that. What drew you into React?
Yeah. So like you said, I was way into AngularJS, and I went to Philly ETE to give a talk about Angular 2, that big new and exciting thing that we were everybody was excited for a very long time. It took them a while to finally ship. But yeah, for me, I first heard about React when I was driving to NGConf. And so I was listening to a podcast and they were talking about this new React thing. And it's like, that sounds interesting, but I'm going to NGConf. I'm excited. I'm going to go do this thing. So,
right.
But I had a number of friends who were really taken with React. And so I respected them and I knew like, there's gotta be something to this if they're into it. So I played around with it, and on their website at the time, it said, give us 5 minutes. And so I did, and I was just blown away. And just like reading the documentation, I remember like taking snippets of it and tweeting those and saying like, this is in the React docs, because they were like just really great ways to think about code, more than just React, but just how to think about managing state over time, stuff like that. And so but of course I was still like really heavy into the Angular community. I had a forums library that I was maintaining and a podcast that I was running. And so I was, it wasn't until I guess I'd just been playing with it on the side, and I finally decided, you know what, I want to do this. This is my new thing. I want to make this shift. Because I in part because I was getting tired of Angular 2 taking forever, but also because lots of the things I was excited about Angular 2, the things that they were going to remove from Angular, they were adding those things back in.
Like modules.
Yep, exactly.
Like, modules. Why is that back?
Yeah, exactly. And there was a reason. It was because people complained about directives having to be listed. If you wanted to use it, you had to list it. Yeah, and I just love that in React, I simply import it. I use regular modules. I import it and I can use it. And I have this blog post titled "Why I Love React" that is on the Epic React website. And the biggest thing is that I see it as simple. React itself is actually there's not a lot to it. You could say it's not familiar, but that's different from simple. And so it may not be easy, but like conceptually, you have these functions that return something that's renderable, React elements. And you create those React elements with react.createElement. And then they added a syntax addition to JavaScript to make it a little easier to use that API. That's called JSX. And so you can learn all of this in about a day. And then the rest of your time is spent learning how to actually build a full application, because React is just that portion of it. But I just really appreciate that. And I feel like you can build something, you can build a simple application out of a simple foundation. It's a lot harder to build a simple application out of a complex foundation. And it's possible to build a complex application out of a simple foundation, but I'd rather start with simple. And that's what React was to me. And that's why I made that switch.
Okay, that's a good point. And, the thing about React, I know, is that it kind of evolved over time to the point where it was really functional. And I remember when I was exactly in your spot, right? I was going to the Angular conferences. I was teaching Angular for my clients, AngularJS, I should say. And all of a sudden, Angular 2, they announced it like December 2014 or whatever. And it took like way more than a year for the thing to launch. And each release candidate broke everything I did in the training to catch up. Like, it's going here. It's a release candidate, right? It wasn't really a release candidate. It was a beta.
Yeah.
And maybe an alpha in a lot of ways. So, it certainly has grown up, and it's really like, if you're an enterprise app developer and you look at it, you see things that you pick up and go, okay, I know how dependency injection works. It kind of picks up. But you're right. React started lean and started simple. And everything else hangs off of it in a way where you can kind of pick what you want to use, which, and again, a classical enterprise developer kind of wants something that gives you a roadmap. But I think that a good JavaScript engineer, understanding how JavaScript works, you can really pick only what you need and include only what you need. What do you think in terms of the pivot to functional components when Dan Abramoff came in from his Redux work and, improved / modified React to be functional primarily? I know there were functional components before, but they were view only basically. What do you think of that pivot?
Yeah. Oh my goodness. It was an enormous improvement. So speaking specifically of hooks, because function components have long time been a staple of React development, and actually hooks as well. It's been over 3 years since they were announced. So it's phenomenal. I remember when I first looked at it, I kind of had the same reaction to hooks that I did with JSX, where it's like, what? But then like 5 minutes into it, and I was like, no, this is great. I love this. So the big thing for hooks for me was that we had this challenge in the React community of sharing code. And so with a class component, you had to spread your logic between the component did mount, component will up, or component did update, component will unmount. And so you could have multiple concerns in a single component mixed through these 3 different lifecycle methods, and potentially 4 if you are rendering something about that. And so like you're connecting to a Firebase thing, and you're updating the document title, and you're subscribing to the geolocation, like all of that stuff to be spread through those 3 things. And so the challenge there is, how do you share code that's split into 3 different places? Well, I mean, you can make individual functions that are called in those 3 different places, but it is very hard to track that sort of thing. And especially if you want to hook into state or something, then things get really, really funny. So we did the higher order component thing for a while. That was really hard from a TypeScript perspective, and also or flow type, or also just like you'd have prop clashes and various things like that. It wasn't very powerful either. Then we had render props. That was a lot better in many ways, but you also had some weird hierarchies, like, should I put this one as a parent of this? Like, it doesn't really make sense. It doesn't really matter. And then you have like the pyramid of doom. Not as bad as what we had with callbacks and having to handle errors and stuff, but
a similar pattern.
Yeah, exactly. But like at the time, I was pretty happy with it. I kind of found ways to work around those problems, and it wasn't really that big of an issue for me. But then hooks came around and said, hey, what if we take a couple steps backwards and look at the whole picture and say, let's do this in a completely different way. And hooks allowed me to say, I've got this block of code, and it's all together. And I want to refactor it so it's like abstracted out, put it in a function. So I just take that block of code and I stick it in another function, and now I can call that function from its originating place, and I can call it from other places as well. So sharing code it was no longer how do you share React code, it was how do you share JavaScript. And that just made it so much more natural. Like you no longer need to have in fact, at the time, I had this workshop called Advanced React Component Patterns. And a lot of the things that I taught in that workshop were made irrelevant because we had hooks, because it's no longer a question of how do you make a custom hook. Well, I mean, I do have an exercise about that just to show people how easy it is. But it's literally just like, take this block of code and put it in a function. We call that JavaScript. Like that's what you do with JavaScript. And so they made things. Now there are things you have to, like, we're trading off different complexities and things you need to understand. We have the rules of hooks and things like that. But for the most part, as a consumer of this API, it's pretty simple. And so I'm definitely a big fan of that change.
It's kind of fun going through a class. Like, I know my training was around the time that hooks was introduced, was when my training was kind of waning a little bit, just because of things we were working on and focus. And it was right before hooks hit. And was big. So I went back recently, took the old training out, and I converted things over to hooks and functional, and then threw it in Remix Run. I'm in the middle of that now. And I'm like, wow, this stuff is really much more concise now. If you look at what it is, I initially kind of resisted it just because I felt, functional was such a fad in the industry, that in good ways and bad, right? So you could have crazy functional syntax in libraries you can't read in some languages. Like I think about Scala, for example. Personally, for me, it's like write only.
So
you have like sometimes your biases get in the way, I can totally see where that's just made it a lot easier to write it, to test it, understand it, to mix in features, or basically mix-ins into your function code, which is really cool.
Yeah.
So you got into React, and you have been involved. Did you create the React testing library? Were you one of the key developers of that?
Yep, I did. So that came out of my frustrations with Enzyme, and I was teaching people how to test React applications and teaching Enzyme as the de facto standard. And when I teach, I typically try to, if I have the time for it, I try to start without the abstraction and then slowly introduce the abstraction so people understand, what role does that abstraction play. Mm-hmm. And I found that in the process of building up to Enzyme, there was like this giant leap from no abstraction to Enzyme, because Enzyme's just enormous and so different from what you actually can do without it. And I realized the last step before switching to Enzyme, the utilities that I built for that were actually really nice. And so I was like, I don't need Enzyme, I'll just use this. Mm-hmm. And so 2 weeks before I went to teach testing React applications to 60 engineers, I wrote this library and then taught them how to use this library I published 2 weeks ago. And so I'm glad that it worked out, because otherwise they may have not been super happy about that. That's where React Testing Library came from. And I realized soon thereafter that so much of what I had built has nothing to do with React. And because React to me is an implementation detail that your users don't really care about. Now that some of your users are developers, right? And so that's why we expose a render function and you pass a React element to it. So that's the developer user side of things. But for so much of what you need to do with what's rendered onto the page, that's what your end users are doing. And that has, like, the user doesn't care what framework you're using. And so that's when I created DOM testing library, and that's the foundation for Vue testing library and Cypress testing library, Angular testing library, all of those. We've got if you have a DOM, then we've got a testing library for you, basically. That's
really awesome. It's good to know that. Okay, cool. So so if someone wants to check out your projects and such, you can look at github.com/KentCDodds, and also your website, KentCDodds.com. But we have you here also because you just recently joined the Remix Run family, right?
Yeah.
So I want to talk about that. I know that the big push has been reimagining, client-side only React as how can we speed it up? How can we get the time to rendering quicker? How can we, pre-render things and do things like that? And so there's tools like Gatsby and Next and other tools as well, and Remix Run now enter the picture. So let's talk a little bit about what Remix Run brings to the table. First of all, it enticed you somehow. So what was your initial thing? You're like, oh, I got to work on this tool.
Yeah. Okay. So it was around April of 2020, right after COVID had decimated Ryan Florence and Michael Jackson's business, their in-person training business, where they had to, they couldn't make payroll for their employees, so they had to lay off everybody, and they're like trying to figure out what are we going to do now with our lives, and for a long time they'd been wanting to build this framework because the existing frameworks didn't offer the user experience that they wanted for the web. And so they started tinkering with it, and it just became this really awesome thing. And Ryan would give me regular demos every week or two of what he was working on, and ask me for feedback on APIs and stuff. And I was more than happy to give it to him because he's a friend of mine, but also because I very quickly saw that what they were building was unlike anything that we have. And so I think the biggest things for me are that Remix enables me to build an awesome user experience and not feel ashamed of the code that I had to write to get there.
Okay. All right.
So like to be more specific, because that sounds like a sound bite, but, and it is practice. I have said that before.
Mhm.
But specifically, the big problem that we have right now is loading spinners. We have fallen in love with loading spinners. Before JavaScript front-end frameworks were a big thing, you'd render everything on the server. The user would see a white screen for a while, and then boom, everything's there. There are no loading spinners of any kind. The only loading spinner the user ever sees is in the favicon.
Yeah, right.
And that's not a great experience, but they, at least when it's loaded, they know that it's loaded, it's ready to go, and they have everything they need. But because it takes so long for the user to see anything, I and most everybody else in the single page app world decided, hey, it would be really cool if we could at least show the user a nicer loading experience than just a white screen and a spinner in the favicon. And so we put all of our JavaScript on a CDN, and we send that through the CDN so it could be really fast. We don't have to wait for the server to do all of its stuff. And so we show the user a useless loading spinner at first before we can render anything else. Well, so then Gatsby comes around and says, hey, we can statically generate this stuff. And Gatsby, of course, wasn't the originator of this idea, but they made it really popular. And so you statically generate it, and you can put that HTML on the CDN as well. And so then they're not waiting as long, and rather than seeing a spinner, they see the finished app. The problem, though, is as soon as you have anything on the page that is user specific, you have to replace that with a loading spinner, because you need to have your JavaScript go and get that data. And so we ended up in what I would argue is a worse user experience, because you do show the user something useful, but as soon as anything's user specific, they see a loading spinner. And unless you're really, really good at making your skeletons, and you make sure that you never have content that changes the height of anything, you're going to have stuff bouncing around. Content reflows, like really bad, and it looks bad. So what would be better is, what if we could take a step back and think about that problem all over again? Why did we do this in the first place? Is because the user only saw a white screen and a little spinner in the favicon. And that was the problem. What if we solved that differently? What if we just made it not take so long for that white screen to turn into what they actually want? And so while we've been toying around with the static idea, the distributed web infrastructure has gotten really, really good. And so for pennies, you can host your app in a real server really close to the user, using services like Cloudflare Workers in particular, or Fly.io, or Dino Deploy, or all sorts of other kinds of tools like this that are able to host your servers right next to the user. And then with a smart caching strategy, even a slow backend can be fast. And so we have some demos of a Remix app being rendered and served to the user in 19 milliseconds.
Wow.
That is faster than some CDNs. And that's server rendered stuff, like user specific stuff going on there. Now, you add some like real data and stuff cached in a KV worker or something like that, and you add another 2 or 3 milliseconds to that. That's like nothing. So distributed web infrastructure has changed the question that we ask when we're saying, how do we make it so that the user's experience of landing on my app is faster? So that's what won me over with Remix, was I can give the user a much better experience, and totally customized. On my website, kentcdodds.com, every single page is unique for every single user. And if I have a typo, I don't have to redeploy the whole app. I can just update the Redis cache of that blog post, and it takes me less than 20 seconds from the time I commit to the time the GitHub action starts up, and it goes through and rebuilds everything. So that is a really nice change. Whereas before it was like a 20-minute thing to redeploy a typo. So that was the biggest thing that got me really excited about Remix. I built my website for about a year. I was playing with it, and then finally decided, you know what? All I want to do is teach people how to build Remix apps, because my entire goal is to help people build the web better, to make the world better with quality software. And I can't do that any better than by teaching people how to build Remix apps, because if you build with Remix, your website will be better. And so that's when I decided all I wanted to do was build with Remix, then I started talking with the Remix folks, and that's what I'm doing now.
That's great. And did you work on these recent tutorials that are up there?
Yeah,
because
so
they're fabulous. I just got to tell you.
Thank you.
Really well written. I love how you pepper things in, like you were talking about before. You'll start with a core kernel of something and say, let's just get a static piece of information up there. Now let's add this hook and do this thing, and we'll add this library to make it easier. Like the blog one is a really nice kind of fun introduction to using Remix and why it's just so interesting to work with.
Yeah.
I'm only that far with it, but it's really, I'm very impressed already. I can tell you have such a great writing style and communication styles. They're very engaging.
Oh, well, thank you. That's really nice of you. That one was actually Ryan Florence wrote that one.
Okay. Well, thank you, Ryan.
Ryan's great. I did the jokes tutorial.
Oh, cool.
And that one's for, so we wanted, when we launched, to have two things. We knew that most engineers, when they're just playing around with it, just want to build a blog. That's like how we play with things. And so Ryan, and we wanted to do that in something you could do in less than an hour. And then we also knew that when it really comes down to it, people who want to actually make some money building the software, they need like an actual app with users and everything. And so I built the one that takes a couple hours to go through. That's the Jokes app, and it has authentication and everything like built in, like you're not using third-party services or anything. Nice. Hand-rolled authentication. And it's pretty, Remix empowers me to do this sort of thing. And I love Remix for that.
So some of the things that I'm just going through the APIs and looking at things, the data fetching is an interesting aspect of Remix. So talk a little bit about how it works, like in terms of at a conceptual level. You're based on the fetch API, right? But it does some things a little differently, right? So for example, API routes and things like that. So is there a way to kind of talk about that for someone who's never heard of it before?
Yeah, totally. So with single page apps, JavaScript based apps, we've gotten really used to having the JavaScript load onto the page, and then the JavaScript goes and gets the stuff that it needs. This is Jamstack. Yep. Jamstack is not good for, Jamstack is really good for getting something to the user very quickly, but not very good for a user experience relative to what we can offer through Remix. And actually, this is the first time I've mentioned this. When is this going to be published?
Whenever you feel comfortable with me publishing.
Okay, well,
if you're going to announce something new,
I won't tell your listeners that right now then, because I'm not sure when we're going to announce this, but we are coming out with our own fun acronym, because Jamstack, while you can build Jamstack apps with Remix, it doesn't quite describe the stack that we're trying to go for. So look forward to that.
Preview.
But so Jamstack basically means spinners for any user specific content. So what we can do is, instead of putting all of our data loading requirements in the client side bundle and waiting for the client side stuff to download so that we can go make these requests, instead we'll just put those on the server. And so as soon as the user says, hey, I want this web page, we know exactly because we're routing for you, we know exactly which of these routes we need to get data for. And so we call all of those on the server. Once we get all that data, then we can render that HTML and send that response. And then we can rehydrate so that it can all be interactive and everything. And so a route in Remix is a module that's using file-based routing. Anybody who's used Gatsby or Next will be familiar with that. But what makes Remix unique is that it has support for nested routing. And so rather than and these other frameworks with the file-based routing, it appears that they have nested routing, but they really don't, because each individual file is responsible for the entire page when the user lands on that particular route. In Remix, exactly. And that's why you have these layout routes and different things. And React makes it easy so that you can reuse components and stuff. But there are a lot of things that you can do if you're using nested routes. And so in Remix, when you're down in the leaf node files there, all you have to worry about is your part of the page that is relevant for the route that you're on. And that also means your data. So you have your export default function component, and then right above that, you have export const loader. And this is an async function, and that only runs on the server. And then within your default component, you call use loader data. and that will give you the data that you got back from the loader. So the thing that's like literally 5 lines above you that says return this object or whatever, that's what you get in the data. And so what's really cool about this is because it's running on the server, you can use any sort of library that you want, as big as you want, doesn't really matter because that's running on the server anyway. And then all you're sending to the user is the data that comes out of that. You can call databases. You can like literally anything, call third-party APIs and not worry about course headers.
Yeah, right.
You can and not worry about securing your keys or any of that stuff. It's all just right there. And if you decide, oh, actually, I don't need this property anymore, then you delete it from your UI and you delete it from your loader, and you don't have to worry about data overfetching either. So lots of the things that like encourage us to create serverless functions so that we can hide our API keys or use GraphQL so we don't have to worry about data overfetching. Lots of these problems are eliminated because we can just run that on the server. And then it ends up being lickety split fast too.
And it's all in one place. So as you're looking at it, your module is your file that contains the client and the server based on the path and route where it's located in the directory structure. So it's very easy to see your URL, find out where it's actually being used, take a look at the data fetching. That's really cool the way that's done.
Yeah. Well, and
really
there's
unique.
no loading state considerations.
Right.
You don't think about the loading state because your component isn't rendered until the data is ready. And so, of course, you can show loading states if you need to. There are APIs for that. But Remix also does prefetching for you, so you often don't, the user wouldn't see that loading state anyway. And to take things further, there's also error handling is handled outside of that default component as well through the use of route error boundaries. And so your happy path stays a happy path. And you're just thinking about, okay, so I've got my data and now I'm going to display this stuff. And to take things even further, it's even cooler because we use forms for mutations. And there's an action function, just like there's that loader function. And so we can, you have your mutation code that runs server side as well. So yeah, Remix has, and that's the thing that frameworks often get wrong or miss, is that they say, oh, let's give you a really great way to load data, but then we'll just kind of like be hand wavy about the mutations.
And your mutations are only going to update that component, right? So if you've got a large tree and you want to just do that update, your changes would be done very locally as well, right? Automatically.
Yeah. So the thing with mutations is like the big problem with mutations, and the reason why I think frameworks often kind of hand wave on this is, what do you do when the user changes data? Well, like all of the data that you have on the page is now invalid. They need to refresh that cache. And so what Remix says is, as soon as you do any mutation, we will instantly invalidate all of the data that's on the page and go refetch it. And that ends up being the right thing to make from the start. And that's all the data that's on the page currently. So it's not like on previous pages or anything else. Remix doesn't. You don't need to worry about that either. But Remix will just go refetch everything that is on whatever page you're going to. So like you create an invoice, now you're going to go to that invoices page or something. So any data that's required there. And so you never think about data and cache invalidation or anything, because Remix handles all of that for you. And because it has nested routing, yeah, it can optimize the way that it's loading data. So if you got a list of invoices or emails, for example, and I'm just changing which email I'm showing, I've got a master detail or something, right. Then I click on an email. It doesn't need to reload all of the data on the page, just the sub route or the nested route, the data for that. So yeah, there's a lot of optimizations built in.
There's this other thing I was reading about, like you can actually, in some cases, not that you always want to do this, but you can disable JavaScript and see some of this stuff working as well. How's that function?
Yeah, so it's super cool. For a lot of people who've just joined the web world in the last like 6 years, and you may not know this, but the forums and browsers actually know how to submit data to the server.
Yeah, right.
So that thing where you say, okay, here's my form and here's my onSubmit handler, and I'm going to say event.prevent default. The default that you're preventing is the ability for the form to do what you're about to do, right?
Yep.
So like your first line is prevent the default, and then the next 20 lines is do what the default was going to do.
Exactly.
The difference, of course, is that with the default behavior is a full page refresh, and that's what we're trying to avoid there. And so what Remix offers is we say, hey, let's not or let's make our server understand the default behavior, and then we'll make it so that what we do does the exact same thing. And so your backend, which is Remix, it's just that action function that's literally in the same file as your form. That action function will work whether you do the prevent default or not. And you don't, of course, have to do the prevent default yourself. And so what's cool about this is that you're using this Remix form, and that renders an actual form element. And then when Remix is on the page, like JavaScript is there and it's hydrated, Remix will say prevent default because I don't want the full page refresh. And I will make a network request to the Remix server, and Remix will handle it exactly as you would expect. So like your action function's called, you get the request, you can get all the form fields and everything. But here's the really cool thing. And you mentioned like it works without JavaScript. Yes, it does. So if there is no JavaScript, then we can't prevent default because it's not on the page. And so it does a full page refresh, it does the post, and it codes the form, and everything works exactly right. But here's why this is cool. It's not because you can disable JavaScript and we think that's awesome. Not a lot of people do that. There are some, right. And JavaScript will sometimes fail to load as well. Like that has happened to all of us. Everybody talking, listening right now, JavaScript has failed to load. Like if you've ever been using your phone and you click on a button, nothing happens, you hit refresh and it works that time. That last time, it was because the JavaScript failed to load for some reason. It happens all the time. But what's even cooler is that it means that our apps will work before the JavaScript loads. And so what this means is if I'm on a bad network connection and I get the app loaded and I'm like slowly loading that JavaScript, I can use the entire app and it will completely work, and even though the JavaScript hasn't loaded yet.
It's true graceful degradation. Yeah.
Yes, exactly. This is what we call progressive enhancement.
Right.
And so we can progressively enhance it so that once the JavaScript is loaded, we can, we have a nicer experience. We don't have to do a full page refresh. We can do optimistic UI, all that sort of cool stuff you can do with JavaScript, have actual accessible stuff. And then there are some things that won't work without JavaScript, like modals and accordions and some things you might be able to do an accordion that works without JavaScript too, but there are various UI elements that won't work without JavaScript. And so there are some things you'll be a little bit stuck, but for the most part, like your login screen can work without JavaScript. And the reason that I think that this is so magical is that a lot of frameworks for many years have been focused on how do I get my framework smaller and my user code smaller so that I can get to the browser faster and it can parse quickly and everything, so that performance, that's what we're going for. Like make everything smaller, it'll go faster.
Right.
But what if you can make it so that your app works without JavaScript? Well, now it doesn't matter how much JavaScript you're sending. You can send like a giant blob of JavaScript, which is probably not great anyway. And so like, I'll come back to that in a second. But sure. Even if you do, the whole app will still work. And so it's not a performance issue anymore. Now there are other reasons you don't want to do that, but like primarily your app works. So you don't need to make things small for the performance reasons. And to bring it back around with Remix, you actually send less to the browser as well because so much of your logic is on the server anyway. And so you don't need a bunch of libraries and stuff to bring into the browser. You can use GraphQL, but you probably can just use it on the server. And so you don't need the enormous GraphQL library
exactly.
that everybody's sending that goes to the client. So with Remix, here's the key takeaway. Like we bring it all back. With Remix, you send less to the browser. Your app works before the JavaScript loads as well. So that's like the big thing. And we typically don't like sharing things until it's shipped, but I'll just mention this as well. We have figured out a really nice API for streaming. And so you can start streaming your response. And what's really great about this is that as soon as the browser starts downloading the document, we can actually also add special headers to that response that say, hey, here's the document, but here's also all of the JavaScript and CSS and data that you're going to load. So go ahead and prefetch those too. So while you're downloading the document, not while it's parsing, but while you start downloading, you're also downloading all the CSS and JS and fonts and whatever else you need. So by the time the document is all downloaded, it's actually also rehydrated and styled and everything. So like this is ridiculously fast and better for the user experience. And then of course you're downloading less from the start as well. So anyway, I should have warned you at the start. I can talk for a long time.
You clearly hate this framework.
Yeah.
So, all right. So this, let me ask another angle on this, and we can wrap it up after this. But like when you're serving this, so there is a Remix Run server that's node based, right, by default. But you also have adapters to all sorts of different web frameworks. Or web platforms, I should say. Talk to me about that a little bit.
Yeah. So one of the big and important parts of Remix from the very beginning was we wanted to found this on web platform APIs. So that's another thing I love about Remix is that the better you get at Remix, the better you get at the platform, the web platform. And so rather than building our own request response sort of thing, we're using the web platform request response APIs. We're using fetch, we're using headers and URL search params and all of that stuff. So like so much of the Remix documentation is on MDN. And so I really appreciate that. And by building things this way, Remix can kind of serve as like the jQuery of platforms. So we normalize the platforms for you so that like every one of these platforms, serverless or real node, Express, or Cloudflare workers, so like even non-node JavaScript environments, all of this stuff can be normalized for you. So most of your code in the app directory is going to be the same regardless of the platform. So that's where it's like jQuery for platforms. And so it's kind of like a learn once, deploy anywhere, and maybe even code once, deploy anywhere in some cases. So yeah, we deploy in like an actual node environment, a traditional node like Express app or whatever. But we also deploy to Cloudflare workers, and soon we'll deploy to Deno deploy, which is another JavaScript environment that's not node. Yeah. Netlify serverless functions and Vercel functions, AWS Lambda, like pretty much anywhere that JavaScript can run and you have a request response sort of experience, you can deploy Remix to. Eventually we'll deploy to servers, wait, I lost it. Workers, service workers. Is that what those are called?
I think so. Yes,
yeah,
yes,
like,
yes.
I don't know where I literally said that like 2 hours ago to somebody else.
It's okay.
Yeah, but we'll deploy to service workers as well, which means that you could do like a totally client-side offline app experience with Remix because we just rely on request response. So yeah, that is a key piece of the Remix puzzle there too.
Cool. So Remix Run is at remix.run. Great URL for it, since it's the name of the product. As I mentioned earlier, there are a lot of like demos there, and documentation samples, tons of GitHub examples out there. I'm glad to hear that you're working on this project. This is you can run on any platform, as you'd mentioned. You don't offer like a server platform or anything like Vercel does right now, right?
Not right now, no.
Okay.
But I'm not afraid to say that is in the future for sure. That's right now we have no way of making money, and eventually we'll need to do that.
Right. But it's good to know you guys are putting such effort into this, and it's really been thought through quite deeply. And love to keep track of it and see where it heads over the future. So that's fantastic. And do you have like I guess there's a blog out there for it too, kind of talking about the philosophy and things like that?
Yeah, the philosophy and the technical explanation, probably
on the pages section. Yeah, I see it here. Okay, cool. All right, Kent, I really appreciate you taking the time to talk about it. Sounds like a great project.
Thank you. And thank you for giving me this opportunity to talk about something I love. Clearly, I enjoy doing that.
Awesome. All right. Thanks again. Let you go. There I am. Hello. So there we go. That was our interview with Kent C. Dodds. Again, you can see his website, kentcdodds.com. He writes and has courses and all sorts of stuff out there. He's available on Discord. Great guy to talk to. You can learn a ton from him, especially about Remix now that he's focusing on Remix Run. Wrap it up here. Again, thanks for being here and paying attention to the TechCast. You can see us on Twitter at twitter.com/TechCast. That's certainly where we're available. We'll take feedback there. You can email us at techcastfeedback@chariotsolutions.com. One quick other note, make sure you check out our blog. It's chariotsolutions.com. You go over to the resources blog. You will find a ton of useful stuff. We've been very active in our blogging, especially recently. So you'll see topics on Amazon Redshift serverless by Keith Gregory. I've been focusing on functional React components and Next.js. And we have topics on like serverless databases, IoT, Redux, and Aaron Mulder, our CTO, talking about the Log4j issues, and as well as Keith Gregory as well. So tons of stuff there. Hit our blog up. You can also hit us at youtube.com if you haven't found it from here, /Chariot Solutions. There you can find all of our videos. We've got a billion of them, playlists. Our entire conference for Philly ETE over the past, 7 or 8 years at least, is all archived here. So Philly ETE 2021, you missed it, no big deal. Go ahead and watch everything from our keynote by Alan Kay and Amber Case to all sorts of topics. You name it, it's all on there. And you will find our videos there under the TechChat Tuesdays. So for Sujan Kapadia and myself, Ken Rimple, I wish you a good couple of weeks. We'll see you in about 2 weeks with our next topic.